So maybe now a lot better, I guess.
So can you hear us? Okay, now we are at 70%. Okay. Very good. It's hopefully now better. But yeah, okay. Now the yes marks are okay. So I will close it. And then we will proceed or continue. So
okay, so super. So just very short introduction. So my colleague Christian, he has to do himself. I'm Oliver. Most of you, I guess, know me from Snom because I'm there quite for a while. And last couple of years, I sort of focused a bit on M900 and multicell, and mostly complicated and as big as possible project, let's say. And we've somehow succeeded quite okay. And today is a follow-up on that because we have something new. So, Christian.
Right. So, okay, from my side, my name is Christian Rapp. I've been at Snom also like a couple of years, and I did in the past the sales stuff for the DACH region. Now I got a few new colleagues, and so the colleagues I changed to this project and consultant job, and we support the partners as good as we can in the project. So if there's something which sales couldn't answer, they will introduce Oliver and me or involve, and we will help as good as we can to support you in the projects. Okay.
So then, what is it all about? So our multicell now can do or can support location-based services. For this, we have new products which we will introduce you to, and so it's let's say it's a completely new story. Yeah. For those who use M900 Multicell, they know that we have had a journey from a rather small system to very large system to a more complicated system to whatever flexible system. So that was quite a journey, and we didn't stop. We just moved forward. And why is that? Of course, it's requirements from our customers. So you actually asked us to have in the very early days cordless telephony. Then later in difficult environments. Difficult environments is, for example, a full steel warehouse or a hospital where a call cannot break because it might cost someone's life. It's not that bad, but you have to be careful, a lot more careful than in the typical office environment. So you basically came to us that we should try to get all those new verticals and more complicated verticals also done with the standard product. Okay, then the next thing you asked us for was conscious and unconscious alarms. So if you have a mobility system in difficult environments, there might be a reason to get alarms. Again, if you look at a hospital, I need to find the doctor if something happens. He's somewhere, maybe your hospital campus is like 20 buildings or 10 buildings. We have one with 14 buildings, and the doctor needs to be called. Of course, he needs to be reached. But what is even more important is that real annoying alarms come to his mobile or to supporting nurse mobile all the time until they finally know where to run and where to help. So how did that work? That worked out quite nicely, but it was a way to go and a lot to change on our side, and most important of all, a lot to learn. And alarms is one thing, but the handling of alarms, that is something which is a lot more complicated. Escalation. What happens if someone in a industry complex in front of a machine gets his arm or hand sucked into whatever dangerous machine? Then the alarm alone is not enough. There must be an escalation. Who can help? How? Up to, I call the local 911 service that they really come and let's say rescue me. Something like that. The full escalation can only be done with a professional system. So professional handling of alarms. This is something Snom, because we do hardware, cannot really do. So, but for we have the devices to actually support professional systems. Yeah, and luckily in the early days, let's say the only device we had was an M85, which had a nice red button where you could push that it sends out an alarm. It could make a call to whatever number inside the multicell, but that is not enough. It was more important to have an interface to a real professional alarm system, which gets more information about what happened with the alarm and what kind of alarm it is. Because the M85, as you probably all know, also has a gyro, so it has a deadman sensor, which finds out if you're not moving anymore, if you fell down, if you're running, if you just keep total silence. Yeah, and this thing basically automatically, unconscious, can send alarm if something happened to me, or by pressing I can do a conscious alarm. I see something and then oh wow, maybe fire is going on. Yeah, so conscious and unconscious alarm is one thing, but conscious alarm, so a red button, we did not have in older and more cost-effective handsets. So luckily, we introduced a completely new series of handsets, which you certainly also know already, and they have one big thing. They all have alarm button on top, which can be used, and they are really shock resistant. That is in the new environments we are taking a big role now. So like industry is really appreciated. So better, more shock resistant handsets with alarm buttons. On top, they have Bluetooth. So they support Bluetooth, not just handset, but also Bluetooth beacons. And that's basically what we need for our new, let's say, solutions. So, but today, or let's say yesterday, we just had very nice handsets, cool multicell, super functionality, and good connection to professional partnership with alarm server providers, because they do the escalation. So the overall, let's say, project was always Snom hardware, some integrator, and then an alarm server of the choice of the hospital or alarm server provider, which was known by the integrator. So that was a very nice one. And of course, we learned over time that there are quite a few. Here's just a few logos of these typical professional alarm server, escalation, legacy system, whatever company, they know how to do. This is something Snom has no idea about, how to really do that correctly. Yeah. Interesting enough, if you maybe look them up later, most of them come from Switzerland. So something about alarming in Switzerland and maybe trust, something cries for Swiss technology. Naja, who knows? Yeah. So, but of course, our customers are not sleeping. They of course wanted advanced requirement. So far we had alarm. We had a very nice cooperation, or we have a very nice cooperation with alarm system providers to give the full solution a very professional and let's say the final touch and the final technology. So, but it's a DECT system, and there's alarms, but you don't know exactly where people are. You send them SMSs, give them locations where to walk to. But what you really want to have is, if something happens somewhere, you would like to know where people are. So people asked us, customers, of course, we want to have location-based information. So forget the S here, it's just location-based information. What is location-based information? In this case, can simply be, now the alarm happened in near the base 1 in building 5. Yeah. So and they wanted clear solutions for example, for a man-down alarm. So M85, you drop down because maybe heart attack or something, and then the handset automatically sends to the system as precise location as possible of your current accident, of your location. So like this, we had basically a typical office like this. We had two M900 via DECT. You know, DECT is very good in range, so you don't need many of the DECT stations, and it can cover a huge area. Yeah, so inside it might be 50 meters radius here. It might be even better. So what happens if I have an accident at this point? Yeah, I'm here and something happened to me. Since it's DECT, the accident itself could have happened at the same distance to this base. So I could lie here and let's say breathing heavily. I could also lie here breathing heavily, and of course I could lie here breathing heavily. So the problem of alarm and positioning with a DECT system is that these bases, they have such a nice range that at the end of the day you cannot really tell where the accident, the incidents happened. It's somewhere on this radius. Yeah. So it can be a huge area. Just imagine this is outside. Outside you have easily 150 meter radius, easily. It goes up to 300 even, depending on clear weather, etc. And then no one really knows where you are. That's why the typical project with a location which was based on the DECT reception could only tell you something like, Naya, it's building 1 and maybe in between 1st and 3rd floor. Because even, you know, it's 3D, of course, because even in the direction up and down, the base goes through the roof, goes through the walls easily, and Naya, it's not quite clear where something happened. So we gave this our customers, of course, and they were only half happy. So what we need is, we need an extra way of get a more precise location. And an extra way to do that is just to enhance what we have already with something, for example, with the typical Bluetooth low energy technology. Bluetooth low energy, BTLE in short, is something which is around for quite some time, and basically does nothing else but sending a sort of ping, a Bluetooth, a mini Bluetooth packet, and this packet gets received somewhere, and then you can find out where the packet came from, and at what reception, how far it might have been, etc. So we had to introduce, or we introduced a new product, and this is the M9 Beacon Gateway. Why does it have such a complicated name, M9B and Beacon Gateway? Okay, first of all, it can receive and send beacons. So these Bluetooth pings, it has, because it's a multi-cell device, it has full connection via an M900 DECT cell, just like a normal DECT base or a DECT handset. So wherever you want, you can place this thing. It will connect via DECT on our multi-cell. So very convenient. But what is even more convenient, because now we are in Bluetooth technology, it's no longer DECT, let's say, we can now say that we can actually find out and measure things happening within a completely different range of different distance. So we put here something like, you can say, okay, it's like 50 centimeters to like 15 meters. Yeah, it can be even a bit more precise, but it's no real relevant application on that, let's say. So because Bluetooth, as you all know from your Bluetooth headset, if you walk away from your mobile, for example, for your headset, interesting enough, with 10 meters difference, sometimes in my flat, I still get excellent music, or can still do phone calls. Yeah, because Bluetooth in this smaller distances, so from 0 to 15 meters, is actually very, very nice. It gets even better if you're near, even nearer the source. So then this device doesn't just send and receive Bluetooth beacons with this precision. It also has 4 integrated antennas. What for, you will see very soon. Yeah, why should a thing like that have 4 antennas? We got that question quite often. But naja, beamforming, you know, is something modern, but it really makes sense. We come to that later. What is also good, because this device, don't forget, it's a device you can put anywhere. It's DECT. It's basically a mobile thing you can stationary put somewhere. So whenever I want, I go to whatever room and put the thing in there. So, but it still is DECT connected, and it also has Bluetooth functionality. Of course, it needs electricity, so it draws power, and it does draw little power, but not as little that we don't have a power supply inclusive in the package, which is very, very handy. Because in a real deployment like a hospital, you want this to function every time. You don't want to swap batteries or whatever. Yeah. Still, the thing can be battery powered, and we recommend to use 2 normal batteries to even do an uninterruptible service. So let's say it's connected by a power supply anyway, and you need to put it from room 1 to room 2. So for example, when you have the batteries inside and pull the USB, the main power, then it will still go on, because it's battery powered. And so even in this, it would be an uninterruptible service. That's just a nice detail, let's say. Normally, you find a way where to put those things, and then it's there, like a DECT base. Yeah. So for those who are familiar with these Bluetooth pings, the beacons, there's different variants of beacons. And iBeacon is, for example, that's the Apple one. Then we have AltBeacon, that's the Google one, and Eddystone is whatever other beacon. It's just a standard. This thing here can send and receive all of those. That's very nice. So there is no, you don't have any, there's no restriction. You can use your iPhone, let's say, you can use your Android phone, and with the right application, you could find out if a mobile is nearby, your laptop could be tracked, whatever. Yeah. So, but why are we doing that? Just to reiterate, we had this DECT, and DECT had huge areas, and we didn't know where people are. So what we do now, we add this extra Bluetooth technology, let's say, to make sure that in the important rooms here, for example, meeting room, could be in industry near machine 1. Yeah. Here at the entrance and exit, we put extra, let's say, location better location providers. So, and they have of course, a completely different area they are looking into. And now you can see some of them have the typical circle thing, yeah. But as you can see, it's, what is it now, 5-6 meter maybe, because it's with the 4 antennas, it's tuned to this room, yeah. So that when someone comes into this room, then this thing will find out, oh, here is something happened. And it's exactly what we have now. My accident, let's say, happens here, yeah. Since in this case, I have a Bluetooth device with me, which gets recognized by this one, yeah, or vice versa. And this new device can easily talk to our DECT system, because it's part of the DECT system. That's the beauty. Yeah. So it talks to the DECT system, and then we can say, now it's very clear. I'm here in this top left room. Here, exactly in this room, the problem or the accident happened, and all this, of course, went fully wireless. So no extra cabling, no extra complicated system, nothing. Just one more, if you need a precise location, for example, in your lab, so the typical, let's say, the typical office plus lab, you would have a multi-cell in the whole office, but in your laboratory, where there might be dangerous substance, people play with dangerous substances, you just add one of those Bluetooth precise location receivers and senders, and all of a sudden, you know, when something happened, I know the guy was in the lab or is in the lab and not somewhere else. So just think about the applications you already have with your customers. Christian?
Yep.
You wanted to question?
No question, no.
No question. Okay, fine. So this already exists with a couple of our alarm server providers as a full solution. So our alarm server providers already give you basically even precise location with their systems. That's very nice. We can connect you to them if you need something, let's say, ready-made. Yeah. But let's look into the how is signaling working, a bit into the technical details about that. Yeah. So let's say we have this M9B. In this case, it sends beacons out. So all the time, ping, ping, ping. I'm here, I'm here, I'm here. And now I walk with my M85, for example. I walk around and I press alarm, or I unfortunately fell down. The alarm needs to get off, and before the alarm gets sent to our DECT system, this handset finds out, there is a Bluetooth beacon very near, so this is a precise location. So now I have an alarm with a precise location. This alarm with the precise location will be transferred to my base, normal DECT base, can be any base in the multi-cell. It's totally transparent, nothing to configure. And the base then knows via an extra protocol how to talk with the alarm server people or with DECT messaging server. You might want to provide your own solution with. Yeah. So this is one way of doing it. The important bit is that here, at the end of the day, in whatever message server and database, you will have the correct data, nicely timed, that at this location with this guy something happened, for example, a man down alarm, and you can use that in your whatever system underneath. Or you have anyway a professional alarm server provider which puts this in whatever escalation workflow. So
Oliver?
currently, yeah.
One question. Will you lose a channel on your DECT antenna, so in case of using BTLE gateways?
Okay. No, you don't have to. Let's say there's more things to that. One thing is a typical M900 multicell has ability to add up to 1,000 mobile devices, so handsets, 1,000 pieces. So if you add another, let's say, Bluetooth receiver or sender, in this case a sender, then this 1,000 is still 1,000. The only difference is that this thing here might have to communicate via either data or provisioning data or whatever. Yeah, and for this the available DECT channels will be used. So you could think of, let's say, my DECT base today, my single base can do 8 parallel calls, yeah, easily, let's say. And I have extra things of those also connected via DECT. Then they might also maybe block the channel, or the channels are blocked and nothing works. In this case, a typical base has not doesn't just have 8 parallel channels for calling, but it also has 2 extra channels, for example, for roaming. And those channels are used by these devices as well. And why is this working? Non-blocking, let's say. Very simple, because those devices, they send very little data. It's just really, it's also like a DECT ping even. There's Bluetooth ping and there's DECT ping. So very short package, and then they're off. So they basically wait until they can send, and that's why, in principle, the whole thing is totally transparent. So you're not losing losing anything. If you want to make sure, we normally tell people that if they cannot believe that it's really so easily working, yeah, then just in the sizing of your project, make sure that your multi-cell in really call dense areas is limited to, let's say, 6 parallel calls instead of 8 parallel calls, because then you have plenty of extra DECT capacity and channels free and open for who knows how many of those, but easily like 50. Yeah. So the general answer is no, it's not hindering you. But if you want to be absolutely sure, just to make sure that your sizing of the multi-cell is more like not at the edge, but maybe 6 parallel calls maximum. Yeah. How to do that, we tell you, or you know already. So
I've got a second question.
Oh, yes.
The M900 is only there for DECT communication, but the location detection is done by M9B. Das ist eine Frage.
Yes and no. In this very special case, the handset receives the beacon. So the handset knows that this device has a location. But we come to another one, which is the more sexy one, because this is permanent positioning information. Everyone might have heard or might have seen RTLS, real-time location solutions or real-time location systems. That's really cool systems, which can do sometimes even precision in centimeters to track devices, persons, everything. So real-time location solution system, we, with our multi-cell, by using our Bluetooth new devices, M9B gateway, we also have that. The only difference is that our precision is not the 5 centimeters, but we still have very good positioning, and our let's say accuracy, the real-time frequency like this is also very good, because we can easily say in a big system with precise location and a lot of people moving, we get updates, let's say, all 2 seconds. So it's not all 2 milliseconds, but it's all 2 seconds. For most of all systems and solutions, this is more than enough. And the beauty is the multi-cell system is already in place. Yeah, your customer has our multi-cell, and he's very happy. And he needs, for a couple of places, he needs real-time positioning. And with this, we can give him. So we have completely new solutions now. We can do geofencing. Geofencing, I had to copy the definition in Wikipedia, because it's so nice. Yeah, basically geofencing only means if someone goes through a gate, it would be good to know that he or the device actually left an area. That's it. As you can see, the real definition is a bit more complex, but means exactly the same thing. So you have a virtual fence, and if someone crosses this fence, there must be, for example, an alarm. There must be some sort of notification. So this is geofencing. It's there's so many ways to use that. And then, of course, What everyone wants, tracking. I want to know where my devices are, where my people are, ideally 2 seconds, 2 seconds exact, yeah. And all this we can do now. So the current requirements for us is very clear. We have a multi-cell system with a tracking positioning system on top. How is that? How is that working? In this case, let's say we do value protection. It's just one application of it. So we have some valuables, as you can see here. Yeah, the diamond, and the diamond has a Bluetooth beacon device stick to it. This is also coming from us. You will see very soon. So here's something valuable, there's something valuable, and now the bad guy comes and he takes your stuff and walks out of your fence, because this is basically geo-fencing, fenced office. So what happened? This guy runs with something which emits permanently ping, 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 I'm here. And this receiver here understood, okay, the guy came here, fine. Now the guy is here, so he obviously left our office. So now you can do all sorts of alarms. Yeah. First of all, he's not allowed to take exactly this device because it has a unique number, of course. Yeah. And now you know that something happened. Actually, we in Snom could have used that because Corona office is not really populated with people, and then of course there was some burglary and we lost some laptops. And yeah, it's a shame, but we didn't use our own technology to actually secure our laptops. So, naja. So then 2 or 3 laptops are gone now, and we did not use our system. How poor, yeah? But that, of course, changed. So, but how can you protect your laptop? It's very simple. We have a small tag. I'm sure you, all of you guys saw the Apple tags. Apple tags and this one is very similar. More or less same technology. This thing here reacts on movement. So what it really does is, if you shake or if you move it, so let's say you put that on a laptop sitting on your desk. If someone takes your laptop, then shaking happens. Then this little thing, this little button, let's say, it's like the size of a €2 coin. Christian, can you show it?
Maybe? Yeah, show it.
Yeah, okay. This little thing then emits beacons. Ping, 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 something happens. I'm here, I'm here, I'm here, I'm here, I'm here. So this is this line, sends Bluetooth low energy bursts to gateway. So to what gateway? To an M9B receiver, like we saw in the animation before. So if someone goes out, there's the receiver, and this thing now says, I'm here, I'm here, I'm here, and the receiver recognizes, oh, he just passed me. Yeah, and then you can do something behind. The interesting thing is that it's very small, but it also has a relatively small battery. So a small battery, if it would fire all the time, if it would always ping, I'm here, I'm here, I'm here, then maybe in, who knows, 3 months time, the thing would be dead and you would have to change the battery. In this case, since it reacts on movement, it's actually very energy efficient. So let's say we had one guy who had a couple of paintings in his house, and he asked us if we can somehow secure the paintings. Of course we can. You just put you just glue one of those things and at the back of the paintings, and paintings normally never move. So this thing will work for years and years until someone starts to move the painting, and then it bursts. I'm moving, I'm moving, I'm moving, and then he can react with whatever automatic closing of gates, etc., etc. Yeah. So very nice things. If you're not sure how that works, just go to Apple and look at their amazing marketing, what they made out of a simple device like that. Yeah. So in principle, this is the same. Yeah. It's just not as cool as Apple can tell. Yeah. Anyway, so now again, for those who want to know what is the flow now. Yeah. So this is me. I'm walking inside my company. my handset is permanently saying, because my handset has a good battery, let's say each second it says, I'm here, I'm here, I'm here. Now I walk in the kitchen. In the kitchen, I have one of my M9B gateways as a receiver. So the receiver understands, okay, Oliver came. Then this thing says, I sit in the kitchen, I just saw Oliver, and sends this to the base. The base just takes this information and gives a bit of extra, for example, the DECT position, and sends that over to the messaging or to the alarm server. And then in the alarm server, I know exactly at timestamp whatever, so 12:01 and 10 seconds, Oliver with his handset account 300 walked through the kitchen, and the kitchen was nearest to this base. So this is very, very precise tracking location. And in our case, because we want to help you get the systems like this running quickly, in our case we have a sort of let's call it rapid prototype message server in Python. It's not super clean code, but it's actually working, and you can easily see how the protocol works. And this is just a view of what can happen if someone moves. And I can shortly try to show you the real one. Yeah, here for example, I have my mobile. This is Dusan. Yeah, my mobile is recognized by my. Maybe I can even show you. Just one second. I try that. Maybe I can show you. So Christian, can you see me?
Yeah, bist da.
So this is my receiver. Yeah, I just have it on desk, of course, for demo purposes. This is my receiver. Here's my tag, which I have on my laptop. Let's say. Here's my mobile. Here's my mobile. My normal DECT mobile I use for calling. Yeah, and the system collects all this information and puts it all together. For example, here is the tag. You could see that I was shaking this one. Yeah, that's why it's now it appeared. It's moving. Yeah, so here you can see how near or how far I'm away from my receiver here, and my mobile. This is this one. My mobile here updates live the distance to the receiver. So I just show you. You see, Dusan is now very near. Let's say now I put Dusan a bit further away. Let's just wait. So and near again, -36, super near. Yeah, and so that's the way it works. So the system, the system gives you at the end of the day a position for every device, every person, every tag in the whole multicell. So just imagine what you can do with that. Yeah. So now, where can this be used? Well, in a hospital. I want to find out, because the doctor has a mobile device which permanently sends beacons. I want to know where's the nearest doctor. No problem. Yeah, because I know his position. All right. Okay. The next thing is my bed. In general, mobile assets can be an X-ray system, can be a bed, can be a pallet in your company. They get moved, and somehow you lose track where you put them. Just give them one of those tags, just like in the picture, yeah, or in the painting. Just put the tag. If someone moves the bed, the tag, of course, will say, "Oh, I'm moving," and then you know the position, the new one. So here you can use it. Then, of course, we still have alarm calls. Yeah, the system can do very nice alarm calls, can send SMSs from a server, from the device itself. So this is just an extra given. Yeah. In the industry, you could actually put all those tags on valuables or assets. We have one customer we will show you very in 1 minute, that you simply know, okay, my building material, whatever, I put in hall 5 near the beacon receiver, section 2, something like that. So I know exact position of my valuables and assets. I can track positions of persons, of forklifts, of whatever moving, really moving devices or people. And I have here on the right side, I can do any parameter control. You know, like in the typical shops, when you walk out and there's some thing in your thing you try to steal, and then there's an alarm going off. It's very similar. It's just on Bluetooth, based on Bluetooth technology. So everyone will know if someone moves out with a Bluetooth device here, they will know something happens. And again, this is geofencing, yeah, just to make sure someone crosses the border, then something can happen. So now that you see that we actually invested a lot of time and a lot of with a lot of interest, let's say, to learn how this system can be applied to real solutions. One thing is a pilot for us to get a better understanding. This is actually a steel company, and they gave us the opportunity to use a part of their I don't know, 5 or 6 different manufacturer halls they have, and just look at that. This is 100 meter across, let's say, to 30 meters. And what they wanted to know is where is my forklift at any time near my important important stations. For example, there's a machine, the forklift has to give new material, the machine uses to produce whatever. Yeah, in this case it's all steel things, so steel sheets get delivered to the machines. So they want to know where's the forklift at what time. What we did in this case here, we needed to find out, we have different ways of finding out the position. One thing is that we could use tags, let's say. You have a forklift and then you just put a tag to the forklift, and if the forklift moves, the tag will say, I'm moving, and somewhere there's a receiver, and in this case, this somewhere is actually the red square. Each red square is one of the receivers. So whenever the forklift drives around here, this thing will be active, this thing will be active, this thing will be active, etc. So very easy tracking way of doing. Just think about an office with different rooms, same thing. Yeah. So tag is one thing. Another one is the forklift driver has a handset. If he has a handset anyway, which also sends Bluetooth beacons, maybe the handset is better. He sits on that with his handset, so we can use that. So he had my handset, Oliver handset, and the forklift itself, Stapler is German, the forklift itself could also emit beacons, yeah, with whatever beacon emitter. In this case, of course, with our M9B as a beacon emitter. And then it's only 1 minute. We made round courses to find out what is really better. Just look at it, yeah. So the forklift now moves when there is a bad picture. There's some bump in the on the floor, and whenever a bump happens, just stop it. Whenever a bump happens, then the tag, because there's extra movement, the tag is firing. So at the end of the day, this is the final position: half here left east, half here left east, half here left east. So what we needed to find out is which device is the best one, which can tell me the most precise location. Is it a handset? Is it the Stapler itself sending beacons, or is it this small small little plastic tag? Yeah. So, and then just it's not long, it's just 40 seconds more, and here you can see that it changes differently. Yeah. Some devices are recognized earlier than others. So here we basically learned in an environment like that, it's a steel company, steel producing company. In an environment like this, typical industrial environment, it, for example, makes no big sense to use those tags. First of all, battery problems. Yeah, one day you have to change a battery. What for the hassle? And we found out that the very best way of doing is that we have M9B as a beacon transmitter directly on the forklift. The forklift is electricity is e-powered anyway. It has a big battery, so there's no power problem. So what came out with this is we can track with the precision they need. We can track all their forklifts, and we help them to create an API into their ERP system to streamline their internal logistics. So now it's very clear, if machine 4 has to produce for customer who knows who new products, maybe 1,000 pieces, then the forklift needs to bring raw materials, and the ERP system at every 2 seconds knows if the raw materials are actually near or not. So like this, they really streamline their production now. It's very nice, yeah. So, but for us, it was learning how is this really working. So let's see if I can move forward. That's not so easy. How to go forward? Wait. Okay. Now, second one, another pilot to really test borders or super difficult way of tracking people. So Christian is also involved in firefighter work. Let's say he's actually quite into it. So he's a spare time firefighter, and firefighters need to get tested regularly on all kinds of things. But one particular test is really hard. They have a sort of obstacle parkour. You can see on the right side where they need to find their way through a parkour when this full parkour is under heat, so not fire but heat and smoke. So you can hardly see anything, and heat is really almost unbearable. And in this environment, you as a firefighter need to still be able to orientate yourself. So these firefighting test department people actually asked Christian, we have all nicely, but we would really like to know where our firefighter inside the parkour at what time, where they really are, because some of the firefighters can't do, and maybe someone collapses. You never know. It's really hot, yeah. And so far, I mean, it's not a big area, but there's a lot of boxes, and they want to know where is the guy who is in trouble, that they can take him out quickly. So we try to take the challenge because it really is something to understand our borders. Look at that, yeah. It looks a bit like ape cages, and it's really like this, yeah. The ape you will see very soon. You have to go as a firefighter through these things. And now they want to know from us, with our Bluetooth precise location, is the guy here, or is the guy here, or is the guy here at any time? So precise location. So I just show you how Christian actually managed, without smoke, of course, yeah, and heat. Look at that, yeah. So Christian tries to go through this parkour. You can easily tell it's not a nice thing, because one of those compartments is like 1 cubic meter. So you have a lot of doors to open, and all this you need to do in full smoke when you are almost blind. So for us, for Snom, we just got the, let's say, the task. We need to know whenever Christian sits in what of those, in which one of those small cubicles, yeah. And I can tell you what we manage is we cannot tell exactly because look at that. Yeah, there's 2 floors. There's 1 meter to the left, 1 meter to the right. Everywhere there should be a beacon receiver. So there's a lot of steel. There's doors which are opened and closed. What we still manage, we could give a location which tells that Christian is, for example, near this path, near this tree, or near this tree, or Christian is here, here, or he already fell down because here's a hole. Yeah. So for us, it was to understand what is our limit on precise location in a very dense room. We can tell something like this is not the ideal thing, but let's say if you have something like 3 meters across, you can work with our location system even in dense environments very, very easily. So that really was a pilot to test the limits. Yeah. So, Christian, let's see if I can forward without that. Okay. So you want to start. So if you're really interested in what we are saying, we are actually saying is existing customers with a multicell. Now you can offer them more precise location. So you basically renew your customer and can come up with new project. Of course, you can start from scratch. You can start with professional alarm server providers, which we will give you names and contact data. Or you really want to have your own unique solution. In case you want to have your own unique solution, how can you start? Okay, it's not too complicated. M900 you have, or we give you. This you don't have. So basically the Bluetooth location receivers. A few tags we can give you, but more important, because the real data is later in a database with a protocol which is very, very nicely defined in this document here. So to get an idea how to, for example, create your own server or your own real-time positioning system, we basically provide you a very nice API to our system, and most important of all, we provide you real help. We can provide the help because we trained that like over a year now with different alarm server providers, etc., and also with end customers, like you've seen already. So Christian and myself can be contacted. We know the system good enough in and out. We can provide sample traces of the protocols, very, very important, can give you information when you have an idea about a project. We will and we should discuss with you about this project, and then simply tell you, with our system, this can be done like this and this and this and this. Let's do it, or forget it. It's for our system, it will not work. Yeah. For example, 5 centimeter precise location. We can't do. Very simple. No. Yeah. We don't do. Real time, yes, but only 2 seconds exact. Something like that. So we will help you. We will help you on your ideas of final solutions. We will help you of implementing. If you want to implementing, we will give you the professional contact if you need alarm server things, so typical hospital and man down lone worker environments in industry. So all this exists. So we are open to everything, because we know that the product alone is not enough. The solution is the important bit, and we want you to have ideally even unique solution you can fork to your new and current customers. And we will not stop reminding people what cool solutions our partner XY, so you, actually did for exactly this industry vertical. We will always tell them, because at the end of the day, we earn on our system here. So let's say that's about it. The interesting thing is, it's not only a document you get and some guy who tells you with lame voice how to use the document. No. We have a lot more. We have a fully working server implementation in Python. so where we can install together for real rapid prototypes, for example, to use that. We can tell, and we have simple JSON APIs to get, for example, to get the currently known location for each device in the system. So your handset, Oliver handset, is in the kitchen, let's say. Christian handset is somewhere in the meeting room. Yeah, all this is already existing, and we will give this to you, and we will help you use that, and we will make sure that if you want to make your own professional system out of it, that we tell you what is the important bit if you implement your own thing, where we, for example, failed. Yeah. So rapid prototypes, you get the tools from us. Real solution, think about if you want to invest. If you want nothing to do with all that, we have the professional partners which you team up with, and that's it. Yeah. So that's about it. I'm sure it's quite a lot to take in. The most important picture is this one. Yeah, do not hesitate to come to us. We will discuss potential solutions. We will discuss how to actually implement that, or what partner we need to get that done. That's the most important picture here. Yeah, and believe me, we have time to help. It will do. Christian, luckily, is also almost full-time assigned to this now. Super. Yeah. So it's today the ideal support situation, which is, you know, Snom, it's not easy. Yeah, but it's really now ideal. So, Christian, we have more questions?
Not yet, but
let's just see. Oh yes, okay, I have one. Naja, almost the usual question. Sorry for that, but this is a very valid question. Let's just see. This little thing, I mentioned it already, but battery life. The battery life depends on how much you shake it. If you shake it permanently like mad, the battery life will be less than half a year. That's at least out of what I can say. Yeah. So if you have the painting thing where it almost never shakes, it takes who knows how many years. 5 minimum, more like 10. So the plastic will rot before it's not working. If you have like in our industry example, let's just go quickly to the industry example. If we have valuables, assets with a tag like that, then it's about how often will those be moved by. I guess you get easily 1 year battery life, easily. Yeah, because this pallet will not move permanently. So there's a couple of bursts, and then the forklift puts it down again, and then it starts sleeping again, and then maybe the next one comes and takes it. So this will easily be 1 year. Yeah. So that was one question. Oh, let me see. Okay. What else can we do? Oh, yeah, that's a tough question. But actually, what else can we do? I also mentioned. You have a multi-cell system. You can do telephony. You can do telephony in complicated environments. Okay, it's all a given. Now you have precise location. You even have live tracking, live 2 seconds tracking. Even this you can do. But where's the action? So what action should actually be fired? So this Hilton example here on the right side, when someone leaves the Hilton without permission, what should happen? Should I automatically close doors? Should I ring big bells? Should I do whatever? So this all screams for IoT. And of course, we are not sleeping. We have all sorts of IoT things here on our own. And since we are the biggest, currently the biggest DECT company in the world, we do we are really looking into all sorts of sensors, of course. So what could be the next step for us? It's very clear. We have alarm triggers. We have triggers. Now we need to steer devices, sensors, to do something with the alarms or to support the alarms. So this is something which is definitely coming. Yeah. But now we focus, of course, on live tracking. Oh, Christian, you have one more?
So one question was if it's only working with M900 or also with 700.
Yeah, it's also working with M700. I just wouldn't recommend it. M700 has only one disadvantage. It has CPU and memory power, which is just not great. It's for the multi-cell, the 200 bases. For this, it's perfectly fine. But if you add extra devices on top, M700 really has to work. M900 has plenty of extra CPU power to do all the extra messaging, all the extra location data, etc., etc. So my recommendation would be, yes, M700. If you have a typical office, like in my lab example, if there's one lab and you need to have an exact position only for this lab, of course it will work with M700, no problem. But if you all of a sudden want to have precise location everywhere with real-time tracking of people, no, don't do it with M700. Take M900. Very simple, very clear. Yeah. The more traffic, the more you have to go to M900. And M900 is anyway, I mean, it's so way better. Yeah. Use that.
So one question is here, is there an ideal location for the beacons to broadcast? High on the wall, ceiling, or does it just have to be in the DECT range?
Yeah, this is actually a good question. Let's see.
That's,
Maybe you can see this a bit here. So ideal location is really something you have to try out. So we have one project, for example, the only demand they have is that when you go out of the elevator, it must be clear that you are in second or not in third floor. So in this case, let's say we take a receiver like that, place it, let's say, left or right of the elevator, and make sure that with these 4 antennas we have, we can have a direction more to the left. Or look at that, yeah, with the exit. This thing looks to the left and exit. So not just across, but more like left. So with the you need to really try that out. So does it make sense for the antennas to look more to the left or more to the right or more across? Yeah. This needs to be tested out. There is no ideal position per se. It has to be tried. Yeah. Okay, so I don't have one anymore. So
I'm not my side also nothing.
good.
No.
So we are slightly over time, of course, yeah, because it's actually quite some. So I'm waiting for your calls and ideas of what you want to do with a system like this, and then we will sit together on the phone, let's say, or in live video meetings, and we'll work on that and make sure that we get nice solutions for specific customer problems.
Okay.
So thanks a lot for hearing us. Yeah. And yeah, go for it.
Have a nice day. Bye.